Right, we set up on the bench now just for testing purposes. The plan is to test all the I/O here on the bench that the machine's going to require, change any parameters in the control, etc. The main one is the tool changing system. I'm going to set a simulated tool changer up on the bench. I'm going to use a DC motor, some sensors, and probably some light bulbs, and basically simulate the tool changer so I know it does what I expect it to do when you call a tool. So then hopefully when it goes on the machine, there'll be less work to do. I'll have to set the servo drives up to the loads, and then it'll just be a case of setting the heights and stuff for the tool changing and the spindle orientation angles and things like that, which shouldn't be a big deal. The more work I can do here on the bench, the less work at the machine. I've only set 3 motors up at the minute. I haven't set the spindle up or the servo drive for the spindle. I fit a servo spindle to it. That orange cable is actually the Ethernet connection to the servo drive, or the Modbus or serial connection, whatever it uses. Right, these are the motors for anyone who's not aware of what I've fitted on the machine. These are 1.5 kilowatt NEMA 42. As you can see, they're a big hefty thing. They've got absolute encoders on them, 23-bit absolute encoders, as opposed to incremental encoders that you normally see on servos. The reason for it, the main reason, is when you turn the machine off normally, if you was to turn one of these motors, when you turn the machine back on, the control will have no idea that that motor's turned or moved. With that absolute, it knows at all times where that shaft is, even when the control's turned off. When the control turns on, it will ask for the position of that shaft and update the control. It does that by having, if you look on the cables there, that's a battery backup, and that keeps the position while the power's turned off. And I've been told by the company that will last 2 years, if it was turned off, which I find a bit unbelievable. I'm not going to test it, but that's what they are stuck on. They're the battery backup. I will show you when I fire it up what happens. As you can see, there's an absolute mass of wires, and I'm just plugging the servo drive straight in. One plug turns them all on, and the other one starts the control. This is the I/O cables. That's one of these cables that's on here. There's another one somewhere that's got some more wires. There's wires everywhere. Some of these buttons are not connected. These on off are not connected. They're just buttons that are on the back. I can use them for whatever. I'll connect them to a 24 volt power supply that will turn on some mains contactors that will turn on the rest of it. So basically when it starts up, I will push power on, which will turn a contactor on, which will control the mains power to the drives and anything else that I want to turn on. Right, so I suppose we better turn it on. Start with the servos. You probably hear the fans kicked in. Now the control starts up reasonably quick. It's faster than most older PCs, maybe not as fast as some of the newer PCs, but still plenty fast enough. So that's it, it's loaded now. That screen will stay there until I push a button. When I push a button, if you just keep your eye about there on the screen, you'll see it says machine coordinates and there'll be some digits, and then all of a sudden they'll flash up and they'll change. And basically what that is that's the controller asking the servo drives where the motors are located, and it updates the position Right now I can't turn that shaft, it's powered up. So when I touch one of these buttons, you'll see what happens. There, you just saw it flick from 424 to 420 on the x-axis, because I'd been twiddling the shaft. Right, the screen is lovely and clear. I don't think this camera is doing it justice. There is also a plastic film on the front, so it's got a bit of reflection going off. But when you stood in front of it, it's lovely and clear. I'm impressed with it, to be honest. The size is spot on, it's big enough, plenty big enough. Screen and all the menus tell you most of what you need to know. I'm not going to run through the control now. I'm going to leave it at this and try and keep the videos short, and I'll do a few. The next one I'll probably do going through the control itself and what most of the buttons do. So that's it, I'll leave it at that for now. Thanks.